good to go, though. All right. Hello, everyone. Hey. How's everyone today? Hopefully doing well. Yeah, I'm doing pretty good. It's been a pretty eventful day so far, that's for sure. I know it doesn't seem like it, but I ended up doing a little bit behind the scenes, but I got all that work done there. So far so good. So hopefully you had a good couple of days yourself. Still, hey, how's it going? How you doing, Diego? There we go. I'm still working it out for it to be faster, but just want to keep it consistent for now. I have a limited connection, so um, yeah, I guess this will be okay though. Good afternoon, Gustavo. You got my email, so or both of my emails. So hopefully that will work out for you once you contact the representative there. So I was working on that this afternoon and trying to get that stuff done. We'll wait for a few more people to come in. It's not time just yet. We got about 2, 3 minutes left, so no worries, no worries. Everybody, hopefully, excellent, good, good. Yeah, so we'll just wait a few more minutes here, and then we'll go ahead and get started here with some important stuff. All right, cool. I'm happy you got that squared away. Hopefully, we'll hear some good news back from the rep soon. So, hello, Ivan. How are you? Hope you're doing pretty good, my friend. All right. I'm very happy to hear that. Hey, that's all that matters. Hey, we're chill, we're happy. You know, we're here to learn um, things. It's been kind of an up and down day for me, so getting just a lot of things done and stuff. So indoors where it's cool. You got that right. Yeah, I don't want to step outside. Yeah, I'm too lazy for that right now. Just like relax on my couch or my computer. There you go. Smart, conserve energy, but I do that every day. They're all stored in my big pocket I got right here. Oh man. Every day you're like, I'm satisfied. It feels great. All right, about a minute away from getting started, so we'll yeah, they're gonna be A lot of people just kind of flooding in here, so that's good. That's good. Hello, Miguel. How are you doing? I hope you got my email as well. Hopefully you've sent that information away. Well, emails actually. So yeah, so yeah, my afternoon is pretty good so far. Just taking care of some work. I'm due. Will class be up to 7:45? Yeah, we'll see. I don't expect it to be up to 7:45 today. Probably, but we'll see. I don't want to like because of the nature of the subject. I don't want to be super overwhelming, but there are certainly important points to go over. So certainly we will address that. So yeah, I'm just doing work, and then on the side, I have a side hustle as well. So was working a bit on the side hustle. So a few extra bucks never hurts. But I'm here for you guys first and foremost. So side hustle doesn't, I don't have to do that right now anyway. So all right, okay, so it's 5:01. All right. Let me tell you the side hustle. Sure, yeah, you could yeah, of course you could ask. My side hustle is so my side hustle is my side hustle is options trading. So that's my current side hustle. So that's what I do to kind of make a little bit of extra money there. All right. Okay. So let's go ahead and get started here for today. Welcome back to Wednesday, end of the week time today. So today, well, actually, let's talk about last time here really quick. Last time we went over the syllabus. I know some of you still having my math lab issues. That's fine. Keep those questions coming. I'm working with any and all of you just to try and get you signed up with my math lab. If you haven't done so already, please go ahead and do so. If you have temporary registration with my math lab, be sure that you know you need to buy the actual full access code. Otherwise, it won't save your work once the expiration for that temporary code goes by. So make sure that you do that. Again, it'll only last, I believe, 14 or 17 days or something like that. So that is regarding my math lab. We also went over chapter one, kind of the basics, our basics plus minus times and divide. So we looked at a lot of examples, kind of did, we stressed a lot of important points, certainly. Um, even though, it's not so hard, it's just a matter of, getting the correct mindset when we start to critically think through uh, various problems. Now, today we're going to deal with the best friend of all best friends. The thing that everybody in the chat loves the most, because I know you guys absolutely love it, and I'm sure I do too. Uh, so today we're going to talk about in chapter 2, we're going to talk about fractions. Oh yeah, let's do it. Fractions the best, I know. Um, can I see if I've done any of the homework? Yes. Uh, I can talk with you after class if you want to know if I see that you did any of the homework there. So I don't have a problem with that. All right, so let's go ahead and go over section 2.1. Will be kind of the basics. Let's talk about the basics of fractions. All right. So we're going to be working with fractions just on the basic level, and some of the little things that we're going to see throughout this chapter that will be very, very important. And it'll tie into a lot of the things that we discussed here last time. All right. So first and foremost, what does a fraction look like in general? Well, you got a top number, you got a bottom number, or you have a numerator, which is some random number, and then on the bottom you have a denominator. There you go. So you have a numerator and you have a denominator. Okay, so numerator's on the top, so you could just put top here, and then denominator here, I'll sometimes refer to it as a bottom, and then there we go. Really not that bad. Okay, so fairly straightforward there at the end of the day. All right, I think pretty easy. So easy peasy. Now that's just the basic of what a fraction is. All right, so what are some fractions? What do they look like? Well, we could look at 4/7, or again, okay, or again, you can look at 1/11. There's a lot of different types of fractions. We could go on with this all day. But the thing that we want to focus on here when we talk about the basics of fractions, first and foremost, is we want to talk about types of fractions. So we know what a fraction looks like in general, but we have to talk about types of fractions here. So the first type of fraction is called a proper fraction. All right. So a proper fraction basically is when the numerator is bigger, when it is smaller, I should say, so smaller than the denominator. This would be a proper fraction. So again, examples of this would be exactly as you see here. 4/7, 1/11. So the numerator here is smaller than that of the denominator, and so that will be representative of a proper fraction. Okay, so by itself, it's not too hard. Okay, pretty straightforward here. So there's some examples there, easy enough. Okay, now let's look at the other side of things. All right, so the other side of things are improper fractions. So improper fractions are just the opposite definition here. So this is basically when the numerator is bigger than the denominator. All right, so when the numerator is bigger than the denominator is what an improper fraction is going to be. So what exactly does that look like here? And let me go ahead and make that a bit smaller there. There we go. So what exactly are some examples of that? Well, examples of that are going to be, again, say, let's just make up some stuff here. 5/4. Okay, that's an improper fraction. Or 17/7. All right, that too is an improper fraction, and that's all well and good. Okay, so these are improper fractions in general. Okay. Yeah, so if you're taking the 16-week course, yeah, so I'm kind of doing the 8-week course here and the 16-week course simultaneously. So I'm teaching essentially a double lesson. So um, that's why it's kind of a bit of both there. So I'll be teaching basically the entirety of the material here within the first 8 weeks, but then I'll restart from the middle of the book there for the 16-week class. So if you want to listen and for additional information, you can work ahead if you feel like it. If you're in the 16-week class, it's an 8-week class. This would be kind of like a normal lecture. So since you're in the 16-week class, yeah, of course, actually, even for the 16-week class, this would be the next batch of material I would actually do, because I actually do chapter 1 in a day. So, because I like to work ahead. So, yeah, you're still good with the pace there. All right. So just yeah, just ask me questions about whatever. It's fine. Okay. Finally, let's talk about the last part of fractions here, which are mixed numbers, and then we'll talk about a couple more things in relation to that. All right, so mixed numbers here basically have a basically have a big number with a fraction attached. A mixed number basically is, in definitions, just a way to represent an improper fraction. Okay, so just another way to represent an improper fraction would be a mixed number. So what are some examples of mixed numbers here? Again, you've probably seen this a ton of times before, but again, hopefully a lot of times here is just to kind of shake out the cobwebs a little bit, just kind of remind yourself, what the story is. So move that around. All right, so examples would be like, say, 5 and 2/5. All right, so 5 and 2/5, or 3 and I don't know, 9/13 or whatever. Okay, so lots of different examples. Again, a large number here with with a proper fraction right next to it. There you go, and that's pretty much it. Why? Why would you do that? It's not what I selected. Okay, there we go. All right. So there we go. We got examples of improper fractions as well, or mixed numbers as well. So again, a big number with a proper fraction, I should say. Okay. So it's not too hard to see the three types of kind of fractions we'll be looking at. Now, admittingly, mixed numbers can be a lot more difficult to work with in a practical setting than it is to use, say, improper fractions and then converting it back into a mixed number. So we're going to be kind of employing that kind of technique, so we can find calculations a heck of a lot easier than maybe just kind of guessing and checking at the end of the day. So it requires many more steps if you try and do it, with mixed numbers, but converting it into improper fractions is actually significantly easier. Okay, so let's go over that here really quickly. So the next thing we'll talk about here is going to be, we're going to convert mixed numbers into improper fractions. Okay. All right. Before I move forward here, are there any questions that you guys have? Okay. No? Okay. Cool. Oh, all right. So if there are no questions, I'll go ahead and move forward here. Now, as is stated here, we want to go ahead and convert these mixed numbers into improper fractions. Let's go ahead and do that. Now, before we do that, though, I'm going to write a generic mixed number, and I'll write it with some letters. Okay, so let's try with A, and then A will be our big number, and then let's imagine B being our numerator and C being our denominator. Okay, so we just have big A being the big number, little b being the numerator, and C being the denominator of that fraction. So what we want to do here is, if we're going to convert any generic mixed number here into an improper fraction, we're going to essentially use this rule. So let's go over that rule right now. Okay, so this is going to convert to, and I'm going to put a little arrow here. Where's that arrow? Oh, there it is. Okay. So this is kind of like an equals arrow here. To convert this into an improper fraction, we're just going to, for your numerator here, we're first going to do a times c. So we want to do that first. So a times c, put that in parentheses there. And then we want to add that to whatever number b is. Again, so a times this denominator plus the numerator. And we want to put that all over the denominator here once again. Okay, and this is going to net us our conversion here from mixed number into improper fraction. Okay, so this is our generic rule here, okay, for all mixed numbers. And this is the kind of context we want to put it in, because calculations putting it into improper fractions are significantly easier than just having mixed numbers around. Even if you're working in a shop and there's a print, for example, and it says, oh yeah, it's 2 3/4 inches or whatever, and you have to like subtract some kind of material off. Well, yeah, it's difficult to kind of think of that in your head if you're not sure what that's going to be. Even if you say, "Oh, I got to subtract 1.5 inches," well, exactly how much should I have left? All right, a a good way to do that calculation in your head fairly quickly is to convert it into an improper fraction and then reconvert it back. Reconvert it back into a mixed number once you're done doing all that calculation stuff. So that's why I like this method a heck of a lot better, because again of the practicality behind the concept itself. All right, so let's do an example here. All right, so let's just do a quick example here. So I'll just go ahead and pick let's pick 7 and 5/6. All right, so 7 5/6 is going to be our guy. All right. All right. So let's go over this carefully. All right. Let's go over this together. All right. So the first thing that we're going to do, let's follow the formula that we have up here. Okay. So first, we're going to take our big number a. That's going to be 7. We're going to multiply that by the denominator here, which is 6. And we're going to add that to 5. And all that's going to be over little c, which is the denominator. So that's going to be 6. So if you do this out, you do 7 times 6, which is 42, plus 5, which is 47. And that's going to be, our answer here is going to be 47/6. Okay, fair enough. Okay. Wait. Oh, okay. All right. Let's try another one. This time, kind of like you guys kind of give it a go. So let's go with 9 and 7/10. All right. So can anybody tell me what is 9 7/10 as an improper fraction? All right. Nice, nice. 97/10. That is correct. Very good. All right. I'm doing well. All right, so let's let's just show off the work here. Again, it's not so bad. So again, we're doing 9 times 10, and then we're going to add 7 and put that over 10. And everybody is correct here. 97/10 is spot on. Okay, nicely done. All right. Now you're probably saying, where, you're just like saying, well, where is this going to be super helpful? Well, you'll see exactly where this is definitely going to be helpful here in a certain problem. So we do have a purpose for kind of meting stuff out like this. So all right. Okay. Next. Yeah. All right. Okay, now the next problem here that I kind of want to talk about will kind of involve a couple of concepts, all right? So let's talk about the first one, and then I'll talk about the second one here as well. All right. I want to do that second, so all right. Okay, so the first concept I want to talk about is basically this is like determining what is larger. So basically we're going to be given two fractions, or two mixed numbers, whatever, and we want to go ahead and determine whether or not those two fractions or numbers are, which one's bigger or which one's smaller, or whatever the case may be, which one's bigger, I guess. So okay, now what's really important about this? What is the big key to take away from this? So there is a huge key to take away from this. Albeit these problems aren't too difficult, it is going to play a very big role here at the end of the chapter when we talk about adding and subtracting fractions. Because if there's one thing I think most people have a very difficult time with, it's usually addition subtraction. Because I mean, um, that usually happens to be like the biggest. It gets stuck in a lot of people's craw because it's like, well, man, how do I even do this in my head, or how do I even set that up in the calculator? That's actually can be a tough time for some people. So which is totally understandable. All right. So what's the big key here? All right, is to put. Oops. That'd be helpful. You want to put both fractions into you want to put both fractions actually you want to sorry gosh you want to have both fractions with the same denominator. One of the things we talked about last time was understanding that context matters. This is definitely one of those things. So context matters. You know, it I can compare 5 apples to 6 apples, but I can't necessarily compare 5 apples to 6 oranges. Okay. Again, because it depends on what context I'm actually looking it over to see exactly what I'm working with. Okay. Um, so context definitely matters here. Now, let's look at an example here, and let's see exactly what what I'm talking about here. Okay. All right. So let's take two of these dudes and let's see how it works out. Okay. And so we got 3 over 2. We want to see which one's bigger, 3 over 2 or, where is that there? Oh, there it is, 13 over 8. Okay. So just to let you know here, this is on page 85. So let me bring up the thing here. So it's on page oops, that's the wrong thing. Where's shoot? Sorry. There we go. Got it. All right. So yeah, on page 85 we can find this number 2 here. So you can see that for yourself there. Why can't I find that? Okay. Okay. Yep. All right. So this is what we have here so far. All right. So let's go ahead and put it in the same context here. All right. So we have 3 halves and 13 over 8. Now again, what's the problem here? The problem is that although we have 3 halves and 13 over 8, they don't have the same denominator. We have 8 here on this side and 2 here on the other fraction. So if we were to compare both of those, right now I don't know which one's bigger because again, they're not in the same, they're not in the same format. They're not in the same context, okay? So we do have a problem there, certainly. Gosh, it's giving me no issues earlier. Why? Okay. In any case, let's go back to our Word document here. Okay. So let's put down 3 halves here, and we'll put down 13 over 8 as well. Okay. So we want to have the same denominator, all right? That's what we want, all right? So the question is, which denominator are we going to choose? Okay, well, here's the big key behind this, all right, if we want to put it in the same context. So this is another key here. So key number 2, always use a multiple of both denominators. Could be more than 2, but always use a multiple of both denominators. Now, this does have a very important effect for what we'll see later when it comes to addition and subtraction. So what's kind of like the takeaway here? So 16. Okay, I'm glad you kind of said that there, Jess. 16 would be a good guess to use, and 16 certainly would be viable. I would totally agree with that. All right, absolutely true. But let's think about it this way, okay? Because the mindset here is I could use 16, and I would agree with you. We could find this. We could find the answer to this problem, no problem. But if we're going to tie this into like adding and subtracting and making this easier, all right, you should big note here, because I will use this. I will use and abuse this. You should always start at the largest denominator and go up. Okay, so the largest denominator and up, those multiples. So I want to start. So 16 is a great idea, but let's start at 8 first. And if 2 goes into 8, we're good. Then we don't need to do anything else. But if it doesn't, then we move it up to the next multiple up from 8. So then we do 8 plus 8, 16. So then we do the 16 after that fact. Okay, so you can see how, like, if we strategize kind of earlier beforehand, it's a lot easier to do, especially like I said, plus and minus. This is where the biggest key kind of comes in. So even though, like I said, it looks very minor because it's not very hard, mind you, but again, it's those little things that do make a big difference at the end of the day. And trust me when I say this, it'll save you a step too. Okay, so the answer here is 8. Yeah, so let's put in an 8. So we have a 2 here, and we have an 8 here. Okay, we want an 8. That's fine, because 2 goes into 8, and 8's fine by itself. So what should I multiply 2 by to get 8? How do I change 2 to 8? Okay, so we want to multiply by 4. That is correct. Okay, right. Now you're probably saying, well, hold up a second. This isn't too bad. All right, but yeah, I'm not going to disagree. It's not terrible. All right, not terrible at all. But I do want to stress another thing. There's another key point here. Again, those small little fundamentals, they mean a lot later on. Maybe sometimes you're struggling with a basic problem or an algebraic problem for whatever reason. You just kind of have to, even if you're like a CNC guy, you get the, booklet full of formulas and stuff, and you got to figure out one of the extra things in there, to program into the machine. And so, you got to do a little bit of algebra there. And if you have a tough time with algebra in general, or you just you just kind of forgot about it for quite a while. One of the things that is important here is that I want to talk about the key to all algebra. The key to all algebra, whether it's fractions, whether it's some random letters, whether it's some random formulas, whether what you're trying to solve for at the end of the day. There is only one word that reflects the key to every single algebraic concept that we'll talk about here in this course to some effect, and that is the word balance. Everything will revolve around that word. That word is balance. You need to balance things out appropriately in a mathematical context in order to find the expression or letter or whatever that you're looking for. And there's formulas and stuff and anything like that. There's that's always striking a balance to seeing what you can do in order to get to your final result. So what does that mean? That means here is that if I multiply the bottom here by 4, well, I need to do the same thing up here as well. If I do it on one side, on the bottom, on the denominator, I got to multiply the numerator here also by 4 for the same exact reason. Like I said, by itself, it's not a very hard problem, and I'm not gonna, I know it seems like I'm harping on this one problem really, really harshly, but that's not really the point behind this problem. The really big point behind this problem is what major implications we're going to take away for a lot of the concepts we're going to see later on. So even though the problem, sometimes it's like the problem itself is simple, but the takeaways from the problem are going to be much more beneficial down the line. And that's really kind of like what I'm focusing on here in this problem. So what we get here at the end of the day is, for multiplication's sake, we multiply straight across. We'll talk about that here as well. But here we get, again, 12 over 8. Okay, so now we have it in the same context that we wanted it. So we compare, again, this is equal to 12 over 8, and we also have 13 over 8. So we see that 13 beats 12. So since 13 beats 12, that means that 13 is our winner. So 13 over 8 is bigger than 12 over 8. And that's all you have to do for that problem. Any questions about that so far? Okay. So hopefully you guys, hopefully it's starting to make a bit of sense here. So even if you struggled with fractions a bit, hopefully it's starting to make a bit more sense. So that's what I'm genuinely hoping for. Okay. Well, let's keep moving forward then, and let's take a look here at the next example. Now you're probably saying the next example, like, Wayne, what the heck? All right. I'd be like, yeah, I know. All right. But I want to do one more problem because it is one of those kind of small little things that's annoying, but needs to be stated anyway. So let's go ahead and do that. All right, so we're going to compare two numbers here for our second example. Our two numbers here are going to be 4 and let's see, 37 over 9. Okay, so 4 and 37 over 9. All right. Now you're probably saying, how do we deal with that? We have one whole number in 4 and we have 37 over 9 in the other. One of the things that's important to note is, so kind of note here for this one as well, if you have a whole number, you can rewrite it as, and in this case here, whatever that number is, and I'll put it in math type here, whatever that number is over 1. So you can rewrite that as that, whatever that number is, in this case 4, but that number over 1 can be written as a fraction just like so. So you're like, well, I don't know how to deal with that because I don't have a fraction in the first number. In fact, you actually do. And that's the key to doing a problem like this, is just rewriting 4 as, say, 4 over 1. So that's exactly what we have here in this instance. we have 4 over 1 and 37 over 9. Okay. Can anybody tell me what we need to multiply by in order to get it in the same context here? Okay. Now the question is, should I multiply just just multiply 1 by 9, right? Sounds good. So just the 1. All right. Very good. That's right. Both top and bottom, numerator, denominator. That is correct. Right. And the 4. Okay. So that's, again, that's the big key there. Is like, hey, you know what? We gotta do an all or nothing. Okay. That's just how it rolls. All right. So we have. I'll go ahead and write this over here so it's a little bit more clear. I know that's not the greatest there. So it's 4 and 1, and then multiply that by 9 and 9. All right, we have 9 times 4. What's that going to be? What do we get here as our fraction? What does 4 become when we multiply that 9 over? Okay. Okay, very nice. 36 over 9 is correct. So we have our two guys. We have 36 over 9 and 37 over 9. And then you can tell what your winner is because 37 is bigger than 36. Okay. All right. So far, so good. Nice. Any questions about that? Where did I put that? Don't know where that is. Why? Okay. It's really weird. Thought I put that there. All right. I guess it was somewhere in the ether. All right. Okay. Nope. All right. Good stuff. Okay. Now I know this seems like a lot of kind of detail here, but again, this is kind of one of those things, we want to get in the right kind of mindset here for fractions. So I know it seems like we're going really slow here, but again, it's just a matter of those little itty bitty details to get you comfortable with the subject that I think for the most part most people genuinely hate a lot. So it's a great hate for fractions in general. Um, all right. Next. All right. So next part here I want to talk about is also going to be important not only for problems we'll see here in this section, but for pretty much every problem for the most part, because in the online homework there, they're going to ask you for certain fractions. They're going to ask you to put that fraction into lowest terms. Okay, so let's talk about lowest terms. All right. Okay, so the question is, what are what are lowest terms? All right, so lowest terms is basically, and I'll put it as simple as possible, dividing the numerator and denominator by the same number that they have in common until you can no longer do so. Okay, so I'll probably put that on the next line there. There we go. So remember, let's go back to our good friend here. Right away, we're going to use balance. Okay, um, that's how we're going to basically met it out. Is we're going to say, all right, hey, there's a number possibly in common between the numerator and denominator, between the top and the bottom, that we can divide out. And it has to be the same exact number. So we can't just be like, oh, I could just divide 2 up here, and oh, I could just divide by 4 down here. Like, no, you can't do that, all right? It has to be the same, or it's a no-go, all right? So let's take a look at an example here. Let's go with the first one here. So yeah, that one's pretty good. So we'll just do straight up examples here. Let's go with 35 over 30. All right, so let's take a look at 35 over 30. What number can we divide out from both the numerator and denominator, both the top and the bottom, that is in common between 35 and 30? Five? All right, nice. So yeah, the recognition here is that, yeah, 15, Ivan, 15? 15 does not go into 35. It goes into 30, though, I agree with that. But 15 does not go into 35. Fat finger, okay, fair enough. I have a, yeah. Me too. Okay, so that's definitely true here, in this particular case. So we're gonna go ahead and, we're gonna divide. Actually, yeah, you know what? I probably should do that. Okay, so we're gonna divide this by 5, and we're also gonna divide this by 5. Okay, so we're gonna divide both by 5. All right. So again, same number. Now you may need to repeat this process again. It's not just a one and done. You may need to repeat, dividing by the same, but dividing by a different number here, as long as they go into both numbers on the top and bottom respectively. So we have 35 divided by 5, which is 7, and 30 divided by 5, which is 6. Okay, so 7 over 6 would be our answer for this problem. All right. Let's do another one here. All right. So how about 45 and 18? So 45 and 18. 9? Okay. All right, so 9 is correct. Now, if you didn't think of 9 right away, that's perfectly fine. I'm going to show you kind of 2 ways to do this. If you didn't see 9 right away, that's no big deal. Okay, so you don't really have too much of a problem here. But if we do divide by 9 straight up, then what we're going to get here is going to be 5 over 2. Okay, so that's, again, pretty straight easy here. All right, but let's say you have a tough time with 9. Let's say you don't see 9 right away, or you're just like, I like thinking with smaller numbers, because everybody's kind of got that preference sometimes. So you could divide by 3. Okay, that's certainly acceptable. Okay, you can divide by 3, and here we would get 15. That's 45 divided by 3 over 6. Okay, so 15 over 6. And then you would see here, you would check again and say, all right, is there any other number in common between 15 and 6? And the answer is yes. You would divide by 3 again. On both the top and the bottom, or numerator denominator. And then we got 5, and then we got 2. So we get the same exact answer. One takes an extra step, but you can work slow as well. So that's also a benefit. Are there any questions about that? cuckoo. Okay, so we certainly have that. We certainly have these tools that are certainly available to us here. At least, starting to understand exactly how we can go ahead and, modify some of, we can make modifications to fractions. We can do some operations with fractions, as you can clearly see. So you can see a lot of those things starting to kind of gel together in terms of just the basics. And I know there's a lot of basics here, but sometimes when fractions can be hard, or especially if you're, kind of figuring stuff out on the fly, then it can be a little bit difficult to do. So, um, and that's fine. Really quick, let me actually ask some of you guys here really quick. How many of you have a graphing calculator? Like I have my like this kind of guy here, like this. Did Does anybody have this type of calculators? Maybe you had it for a previous class. I don't know. Yeah, that's okay. Even if you don't, that's fine. If you don't, that's fine. It's not, it's no big deal if you do or you don't. I just wanted to point one thing out for the graphing calculator. So no, you don't need to get a graphing calculator. You can still have a basic calculator as long as it has the trigonometric functions. You should be fine. Okay, so you may or may not have the calculator. That's fine. For those of you who may have the calculator here, uh, again, one of the things we just talked about here is again reducing fractions. What you can do here on the good old graphing calculator here, all right, so is we're going to put 45 over 18 using the division symbol here. So I'll just kind of put it up here on screen as best as I can. Question mark. Okay, so there we go. All right, so there's 45 over 18. And then what we do with that is if we want to reduce that automatically on the graphing calculator, you can actually go ahead and do that. To do that, go ahead and hit the math key on your calculator. The math key is right here. Oh, thank you for the follow. And go ahead and hit number 1. Number 1 is fraction. And then go ahead and hit enter one more time, and you'll see that it actually pops up as our answer here at 5 over 2. So you can see that it'll actually reduce that fraction for you if you're not sure or you want to make some quick calculations there without having to have all the muckety muck in the way. So just pointing that out as a extra tool in the arsenal that could certainly help you out there in the field. There's a lot of things this calculator can do, um, but I'm just going to try and keep it as simple as possible. So at times I'll just refer to the graphing calculator here, but it's okay if you don't have one. That's not a big deal. I'm just going to talk about simple functions. There's a lot, like I said, this calculator can do a lot of stuff, but we're not getting into like the heavy details here, so no big deal. Does anybody have any questions about the graphic calculator or anything? No? Okay. Okay. Let's take a look at some questions here and let's see if we can figure that out. Okay. So let's look at some application type questions, and then we'll do like a couple of these, and then we'll just move forward. So it's not a whole lot going on in this section in terms of applications, but I think I think that'll be okay. All right. So let's go to the e-text here. Go. All right. So let's go ahead and look at, yeah, that's right. Okay. Don't know why. All right. Let's look at number 5. Let's look at number 5. Number 5 says, is it possible to have 7/8 of an inch pipe with an inside diameter of 29/32 inches? 29/32 inches. Is that possible? So this is the thing here too, actually. Okay, there we go. Hopefully this is a bit easier to see. Okay. So how could we solve for that? How could we solve for number 5 here? This plumbing question. Is it possible to have 7/8 of an inside diameter, 7/8 inch pipe with an inside diameter of 29/32 of an inch? So here's a picture here. It's just a yes or no question, but we have to be able to prove it. No. Okay, you said no. Why do you say no? So the question really is that why can we say no to this particular question? Let's take a look, right? So it says, is it possible to have 7/8 of an inch of pipe with an inside diameter of 29/32? So essentially, with the inside diameter of any pipe, as you can see here, this inside diameter has to be, this inside diameter here has to be smaller than the diameter of the pipe itself. So let's compare those two fractions, 7/8 and 29/32. So let's take a look at both of those. So we'll look at 7/8 and 29/32. So what, let's take a look at our denominator here. What denominator do we want on the bottom in order to compare the two? So 7/8 and 29/32. We want 32, okay. All right. So I have 8. How do I make that 8 a 32? Okay. Very good. Nice, nice, nice. So you're going to multiply that straight up by 4. That's right. And the top and the bottom there. Very good. All right, so let's multiply straight across here. Okay. What do we get here? 7 times 4? We get 32 here. I agree with this. 28. All right. So can a 29/32 inside diameter fit in a pipe with this diameter? Is that a yes or a no? Can 29? No. Okay, so 29/32 is too big. All right, it's too big compared to the actual diameter of the whole pipe, which is 28/32. If it were to fit inside, it has to be less than 28/32. So it's a little too big. So the answer definitely is no. All right, very nice. All right. Again, like I said, there's not a whole lot kind of going on here, but I'm just kind of pointing out some of the important things about context and whatnot. And I think that's probably the only problem I really want to do here, because everything else will be applicable in the last kind of few sections there. So let's take a look here. All right, let's go over the second part here, which is multiplication of fractions. So let's talk about multiplication here and how to tackle those type of problems. All right, now we've kind of already did talk about how to multiply with fractions. It's really not too hard. All right, so let's just discuss it and see what happens. So okay, let's talk about the rule here for multiplying two fractions together, and then we'll talk about the key here as well, because there is a key that goes along with this. So we'll put it all together. All right. Okay, so multiplying multiple fractions or two fractions together will always work out to be the same way, which so let's say we have a over b as, say, one fraction, and let's say our random other fraction here, we'll call it c over d. Again, just random letters. I don't really care what they are. They're things. It is what it is. All right. And what's very convenient about this is that all you got to do is multiply straight across. Super simple, super easy, super laid back, super chill. There you go. Multiply straight across, and you got yourself a winner. All right, so by itself, the rule here is very simple. Okay. The implementation, though, can be a bit tricky. All right, so let's talk about said implementation. All right, and see exactly how this goes, because at least the one thing that we know about multiplication is that numbers get big really fast in multiplication, and with fractions that can be even more complicated. So let's take a look at an example here with some simple numbers, and then we want to talk about how we can actually, you know, work with numbers that are not so friendly, I guess is the best way to put it. So let's look at an example here. Okay, that's fine. So 15 over 16 times, we'll do 8 over 5. Actually, we'll do 8 over 5 to start with. That's fine. Okay. Okay. So let's go over this. 15 over 16 times 8 over 5. Okay, so let's say this is what we're multiplying these two, random fractions together for, whatever reason. At the end of the day, we don't care. So it is what it is. Okay. Now, if we used our rule here, all right, and we multiplied straight across, all right, what would we get here in this case? So let's multiply straight across, right? Let's just do that. Again, you can use your calculator for this. It's fine. Okay, cool. 120 over 80. All right, seems fair. Okay, now we have to ask ourselves the question here with 120 over 80. Can we reduce that down? Is that possible to reduce it to lower terms? Again, we have to ask that question every single time we look at a fraction. Is it possible to reduce it into lowest terms? Again, what I mean by lowest terms, once again, is dividing by a number on the numerator and denominator, the same number, so we can make those numerator and denominator smaller. Okay, so Miguel, Or anyone else? I agree. You can. What can we divide by? We divide by 40. Okay, we can divide by 40. Whoa, but 40 doesn't go into 128. Or oh, I put 128. I'm so sorry. All right, I'm a dumb. All right, 40 is correct. Okay. All right. You just ignore that I make mistakes. Yeah, reasons. All right, so here we get 3 over 2. Okay, so we get our final result here, 3 over 2. Again, you could take smaller steps if you don't recognize 40 to be that number, and you'll still arrive at 3 over 2. Now here's the problem though. Let's talk about the problem with this process. Okay, so I agree with Ivan. You divide by 40, you get your final result, cool. But not every problem is going to be this nice. Okay, sometimes you're going to get really janky numbers, and you just be like, oh man, these numbers are so ugly. And if you had like 962 over 177, you're like, oh my gosh, how am I supposed to figure that nonsense out? You know, large numbers equal larger problems. So I mean, that's just how it rolls. So the key here into multiplying fractions comes before you even multiply. All right, so let's talk about the real key here behind multiplying fractions, including and even in your head. So key here is that you pare down both fractions by dividing by uh, dividing by by dividing the numerator and denominator by the same number. And so that's kind of like what we kind of want to do here. So we can pare down both fractions, and I want to kind of stress that here, paring down both fractions. So if I go back to the very beginning here, okay, if I go back to the very beginning, so let's go 15 over 16. We already know what the answer is, so getting there, we know exactly what should come out to be. I'm just going to look for, I got 2 numbers on the top and 2 numbers on the bottom. That's what I got. I got 15 and 8 on the top, and I got 16 and 5 on the bottom. Okay, so let's take a look at 15. Can we pare down, okay, is there a number in common with 15 that we can divide by on both the top and bottom? Correct. 5. That's right. So 15 and 5 go together. So what we're going to do here is, since we have 15 and 5, and both of them have 5 in common, and that's fine. It doesn't have to be everything, but they both have 5 in common. We're now going to divide both of these by 5. Okay, that's what we're going to do. All right. So I'm going to show you the kind of intermediary step here. I won't do this often, mind you, but this will be 3. You'd end up with 16, and then you'd have 8 and 1, respectively. Okay. I'll probably add to this key here in a second, but okay, now we just ask the same question again. We have 3 doesn't go into 1, 3 doesn't go into 16. How about 8 and 16? Do they go together? Can we divide stuff out? And if we can, what number? Okay, cool. So the answer is definitely 8. All right, so 8 goes with 16, so we can divide by 8 up here, and we can divide by 8 down here as well. So then what do we get afterwards? Well then, afterwards, after all that's said and done, is that you end up with 3 over 2 times 1 over 1. All right, and then once you get to that point there, then multiply straight across because you paired everything down. Then multiply straight across. Okay. So if we just try and simplify before we multiply, then it makes things 10 times easier for us because at the end, we don't need to simplify any further, which is really helpful. Okay, so we don't want to like scramble our brains and be like, oh man, I don't know what the heck I'm doing. So you can do that before that fact and then multiply after the fact, which can be fairly helpful. All right. All right, let's do that. All right, I'm going to do another problem here. Okay. We'll see this a little bit later, so hence why I'm kind of stressing on this. Yeah, okay. All right, so we have 3/8 of 2 2/3. Now, by itself, that's not very hard, but I do want to kind of highlight one thing here that we're going to see later, and that is, again, the math language portion of the program. So of, not oof, though sometimes you feel that way, of means to multiply or product. Okay, so you'll often see the word of there as one of the keywords there, and you'll say, oh, that indicates multiplication. So like oftentimes we talk about percentages like, okay, 20% of 100, you know, something like that. You're actually effectively multiplying in that case. Okay, so we'll definitely see those later, but again, one of the math language portions of the program. Now, in this particular case, since we're going ahead and multiplying these two together, let's do that here. Okay, so taking a look at this problem here, what should I do first? What do you think would be a good idea? How would I solve for something like this? These random two numbers. What would be a good idea? Okay, good. That is exactly right. Very nice, man. Yeah, convert that mixed number. Make our lives easier. Okay, I'm not in the business of making it hard. So yeah, that's right. So so again, note if you do see a mixed number, convert to improper fraction. Okay. So let's convert 2 2/3 into an improper fraction. All right. 2 2/3. What's that as an improper fraction? All right. Nice. 8 over 3 is spot on. All right. So good. We got that. Nice. Okay. So we got 8 over 3 there. All right. So now let's put it all together. So we're going to have 3 over 8 times 8 over 3. All right. Spot on. And, well, what can we pare down here? 3 and 8. Okay, so we can divide 3 here by another 3. All right, because this 3 goes with this 3. That's cool. And this 8 goes with this 8. And that's cool as well. Okay, so we should get a pretty easy answer here, which is fairly convenient. So again, just to showcase, although the work is redundant, I know, but you get 1s for everything, and that is going to effectively equal 1 over 1, which is 1. So, all right, so effectively you get 1 here at the end of the day. All right, very nice. Any questions so far? No? Okay. Open up another window here. Go. All right, there we go. Just had to move some stuff around there. All right, so if there are no questions, let's go ahead and look at the book here. We're going to do a few of these kind of example problems here using multiplication. So let's do a couple of these, and then we'll move on to the next one here. So okay, so I'm going to be on page 91, okay, of your e-text. So page 91 of the e-text. Okay, let's take a look at this. Let's take a look at, let's see here. Okay, that's fine. Let's take a look here at number 6. All right, some electrical trades. All right, so find the total length of 12 pieces of wire, each 9 and 3/16 of an inch long. All right, so gotta find the total length of the 12 pieces of wire, each 9 and 3/16 of an inch long. All right, so what should we do for that problem there? For number 6. How do we set up that problem? Remember, we want to talk about the interpretation here. So how should we set up this problem here so we interpreted it correctly? Okay, that's correct. 9 and 3/16 times 12. And convert the length of the wire. Okay, so both of you are correct. So the length of the wire needs to be converted into an improper fraction, and we're indeed going to multiply that by 12. I agree with both of you. Very nice. So on the base level, this is what it's going to generically look like. But in reality, we need to change 9 and 3/16 into an improper fraction. Remember, you can also change 12 as well to an improper fraction. We kind of mentioned it earlier here. So if you need to do that, you can go ahead and do that here. I'm not sure why it does that. So we got 12 over 1. 9 and 3/16. Anybody have an answer for that one? What's that as an improper fraction there? 147 over 16. Okay. Cool, cool. All right. So let's see here. We can pair a few things down here. All right. We can pare down the 12 and the 16. Okay, I don't know much about 147 off the top of my head, so I'm not going to make assumptions here because I'm like, okay. But I do know that we could divide 4 for both of these duders. So let's go ahead and do that. All right. Well, 4 goes into 147? I don't think so. No. 4 can't go into 147. So, and 3 obviously doesn't go into 4. So let's multiply straight across. All right. So let's multiply straight across, and then we're going to talk about the other half of this question here. So we'll take a look at that. So what's 3 times 147 here? 441. Okay. So we have an answer here of 441 over 4. All right. Now, what will probably be asked in most of the homework assignments is they may ask you to rewrite it as a mixed number. So I haven't really directly addressed that yet, but I wanted to get to a question where it would be like, oh yeah, this is, that kind of last little bit of extra step that we kind of need to take into account in order to like format the answer correctly, for example. Okay, so I'm going to go back to my notes here. So I'm going to go ahead and use 441 over 4, and I'll show you kind of like the simple, easy way. There's like the hand way, but again, you guys are working out in the field and stuff, so really, you probably just put it on your phone or whatever, and you could probably find it rather quick. Now, the nice part about this is that remember how we do multiplication? We've already done kind of the reduction process. We've put it in its lowest terms, so we don't need to worry about that at all, which is very, very nice. But how does it work if I actually want to put a mixed number, again, I should say improper fraction, improper to mixed number? Okay, so the way it works is fairly simple. All right, what you're going to do is you're going to take 441 on your calculator. You're going to take 441 divided by 4. But I don't want to know the decimal version. I just want the whole number. All right, so thing is, let's go over steps here. Step 1, divide, and take the whole number. All right. Step 2, is the remainder is the numerator, and step 3 is the basically denominator stays the same. So can anybody tell me what 441 divided by 4 is? What'd you get as a nice whole number there? So you can again just do that on the calculator there. You got 110. Okay, so you got 110. All right, so you have so if you want to find the remainder there, take 110, multiply it by 4. Okay, because we want to find the remainder to be our numerator. So take 110, divide it by 4, and then whatever that answer is going to be, take 441 minus that number, and that's going to be your remainder. So 110 times 4 equals 440. And then I want you to take that 441 minus 440. So that's going to equal 1. And that 1 is going to be effectively your numerator there in step number 2. And then you just keep the denominator here the same. So at no point should you have an improper fraction as your big fraction there. You should have always a reduced proper fraction for the mixed, converting back into mixed numbers there. I hope that makes some sense there. Any questions about that? Okay. Nope. Good. Can we do another one similar to that? Sure, absolutely. I think that would be a great idea. All right. Okay. Let's do, I think I have just the problem for you. We'll do a word problem here, and it'll still highlight that kind of thing. All right. Here we go. Let's take a look at number 9 on that same page. All right. So it says, how many pounds of grease are contained in a barrel if a barrel holds 46.5 gallons and a gallon of grease weighs 7 2/3 pounds? Okay. So that's what we have here. Okay, so it's slightly a bit more difficult, but the process here will be the same. Okay, so meaning to say, let's go ahead and move this over a bit. So meaning to say we have a 46.5 gallons of this grease. Okay. So 46.5. Oh, my picture's kind of, sorry about that. And then we're going to multiply that by 7 2/3. Okay, so, all right, so we're just going to multiply that straight up to see how much this grease is going to weigh in this particular barrel. Now again, the first thing we're going to do here is convert both of these into improper fractions. How about 46.5? What's that going to be? Forty-six and a half is an improper fraction. (93/2). Excellent. Good, good. All right, and 7 2/3. 23/3. Nice. Okay, that's correct. Okay, let's take a look here. Can we pare anything down before we put everything together? What can we pare down here? If we can, that is. Move that over. Yes, actually 3 and 93. 2 unfortunately is not a winner, but 3 and 93 certainly a winner there. And again, if you need to trial and error that on your calculator, trial and error it on your calculator. That's perfectly fine. Okay, so it's like I don't see that right away. I'm like, okay, cool. Trial and error that on your calculator and see what you get. If you get nice, clean, crisp whole numbers, you're good to go. If you get very messy, janky numbers, no. So that's pretty much how that'll go. So we get 31/2 times 23/1. All right. Okay, let's multiply straight across here. All right, what do we get in the numerator and what do we get in the denominator there? Well, actually, I'll just answer the denominator. That's just 2. No biggie. How about the numerator there? 31 times 23. 713, okay? All right, good. So now what I would like you to do is take 713, divide that by 2. So 713 divided by 2 is what? What's the whole number for 713 divided by 2? $356, okay? And then, I know you guys can see 0.5 and you say like, okay, well that's a half, and be like, yeah, that makes sense. But if you're doing it just in general for any kind of purpose there, you do 356 divided by times 2, that's going to be 712, and then you take that 713 from your numerator, subtract it by 712 to get your numerator there, which is what? Okay, it won't always be 1, mind you, but again, it's just what it turned out to be in this case. So 1/2. So 356 and a half is what we get for, in this case, 356.5 pounds is what the grease will weigh in this barrel. Any questions about that? Okay, good beans there. Let's see here. Okay, that's fine. All right. All right. All right, that one's not too crazy. All right, it's fine. All right, let's go on to the next part here. Yeah, let's see here. Yeah, that's fine. Okay, that's okay. All right. Sorry, just kind of contemplating something here. Just thinking about pace of class here. Okay. So the next part here, let's talk about the next section. We're going to move forward here. And I'm going to make this the last section of the day because I want to devote some time here to adding and subtracting fractions. But I don't want it to be like a very big, overwhelming information dump. So to do another whole chapter in a day seems a little overwhelming. So, but since division has a lot to do with multiplication, it's just going to be a lot easier just to kind of get it out of the way. So all right, so let's talk about division of fractions. All right, so division of fractions by itself is not too bad. Let's talk about the rule here first and foremost, and then we'll see exactly how things play out. So let's look at our generic rule here. Let's go with our regular ABCD. All right, so I guess I'll have to use I rarely use this, but kind of bury the symbol. I barely use this symbol, but for in this case, I will use this symbol. All right. All right, so the rule is pretty simple here. You can't divide straight across. Unfortunately, that's not possible for fractions. It would be very, very hard, and you'd feel pretty bad. But we can multiply with fractions, and we know how to work with that. And that's exactly kind of the mindset you kind of want to put yourself in. So you have AC times, and you flip this second fraction here, and so this becomes D over C, and then you can multiply straight across that you had from before. So you have A times D over, oops, I should be B here. I don't know why I put C. B times C. So, all right, so this is our generic rule right here for all division of fractions of some kind. Now, really quick, let me throw an example here. All right, I want to throw an example here. I want to see if you guys pick up on this. Now, without using a calculator here, just kind of looking at it as is, all right? Just as is. I know this seems a little weird, but again, I want to be sure that you guys are comfortable with some aspects. So, okay. Can anybody tell me what this is equal to? Got 1/2 divided by 2. What's that equal to? Okay. We got 1. Okay, anybody else? One half divided by 2. Okay, so we have 1/4. Anybody else? 1. Okay. I agree. It's one of those two answers. I agree with that. 1 or 1/4, one of those two. Okay, another one for 1/4. All right. So let's go ahead and see exactly what the answer to this is. So the answer to this here is indeed going to be 1/4. That is the answer to this problem, 1/4. Now you'd be probably saying, whoa, timeout. You know what? How does that happen? Well, let's imagine it this way. Okay, if we're going to use the rule straight up as is, all right? If we use the rule straight up as is, well, another way to kind of do this is to organize yourself. So one of the big keys about dividing fractions, and I know this seems weird, is to organize. Organize the fractions using parentheses. So you know which fraction to flip. Because you know for a fact you have to flip one of the fractions. So if I were to look at this and I say, all right, how should I look at this in terms of putting in parentheses? All right, so this is the way I'm going to do it. I'm going to put that 1/2 is on the top, and I'm going to put parentheses around that. All right, so I know that 1/2 is the top fraction, it's the first fraction. And I know that 2 is the bottom. So 2's in the denominator there. But remember, another way to write 2 would be 2/1. So what you actually have here is you actually have 1/2 divided by 2/1. That's what you actually have there. And then all you do is flip that second fraction and make it multiplication. So now that becomes 1/2 once again. So this is why we get 1/4 and not 1. And that's a very look, to be perfectly honest, it's a common mistake a lot of people make, and that's perfectly fine. I just want to go over kind of like those rough fundamentals there. Another way you can kind of imagine it is that if you had half a pizza and you cut it in half, well, now you got 1/4 of the pizza left, not the whole pizza, right? Because you already ate half of it, so it doesn't make sense to get the whole pizza back. Otherwise, I've just ordered one pizza from Lou Malnati's, and I'd have infinite pizza for life. Honestly, that wouldn't be too bad, but unfortunately, the laws of math don't work that way. I could go for some cheese pizza. Oof, I'm getting hungry. Shoot, I'm making myself hungry. Man, I haven't eaten all day, so man's gotta eat. So there you go. All right, are there any questions about that before we move forward? We're going to try some word problems here with division because it's just, again, a rehash of multiplication. So, pizza party. I'm down for a pizza party, man. Totally down for that. You party, you lose. You know, the pizza party makes sense. You're right, it does. I'm just kidding, man. No, I know what you meant. He's thinking of other things. Okay. All right. Let's take a gander here at a couple of problems here from the book, and then we'll wrap stuff up here. Okay, this is on page is this 98. Okay, so page 98 in the book here. There we go. All right. Okay, let's take a good look here at number 2. Number 2 is actually one of the better problems here in this section, and we'll talk about that. All right, so this is a drafting problem here, and this is specifically revolving around scaling. All right, because obviously if you have a print, you can't obviously make let's say the part that you're making is 10 feet long. You're not going to make a print that necessarily is 10 feet long. That would require too much effort in paper, unless it was, something like that. I don't know, but usually you don't get prints that are 10 feet long. That kind of makes no sense. So um, instead, you scaled the drawing. So, meaning to say, if a quarter of an inch in this case on a drawing represents 1 foot, then a 3.5 inch on the drawing will represent how many feet? Okay, so can anybody tell me how I would set up this problem here in this particular instance? How would I set up number 2 here? What would be the correct way to do that? Hmm. Yeah, that's right, Potato. That's absolutely true. You take 3.5 and you divide that by the fourth. Again, let's answer the question here. Okay, let's answer the question here. You have a quarter of an inch is equal to 1 foot according to the drawing. So you have that, kind of small quarter of an inch. So how many of these little quarter of an inches do we have that make up the full 3.5 inches on the drawing? Because each one is going to be 1 foot according to the scale. So that is exactly correct. Very nice. All right. So that's what we're going to do here. We're going to take 3.5 and divide that straight up by a quarter. Okay. So what do we need to do first? How do we solve for this? Okay, what's 3.5 as an improper fraction? I agree with that. Seven halves, okay, that's correct. All right, so we have 7 halves, and then we'll divide that by, well, actually, what else should I do here then? I have 7 halves, true. All right. What else? I'm dividing by a fourth, so what else do I need to do? Yeah, that's right. So we're going to change division into multiplication, and we're going to make that 4 over 1. All right, flip the 4 over 1, spot on. And can we pare anything down here in this calculation? 2, correct. Very nice. Can take out these 2's here. And so we're going to get, let's take a look at what we get here. So pretty straightforward after that. I don't think you guys will have too much of a problem here. And so here we get 14 feet would be our answer for that. Any questions about that? Nope. Okay. Let's look at one more, just one more. Okay, not too bad. Just one more, and then we'll call it a day here. So because I'll do 2-4 tomorrow. If you guys are okay with that, of course, though. You guys cool just kind of ending off here at 2-3 and then starting up at 2-4 for next week? All right, cool. We'll roll with that. All right, sure. Well, we'll just yeet myself right off the platform. Yeet. Yeah. Indeed. Yeah, that's right. You didn't mean it that way. Hey, look, I don't know how you meant it, but I interpreted it that way, and now I'm very offended. No, I'm not really offended at all. It takes a lot to offend me, and trust me, that's not definitely not one of them. I'm I'm angry at everything. All your comments. I know all of you are talking behind my back. Mm. You're actually sad. No, don't be sad, please. Please, bro. Help me help you. Hey, don't worry. This is all about kind of shaking out the cobwebs and stuff. Getting these basics down and stuff. Don't worry, man. You good. You good. You good. The only thing I worry about is if I eat in my bank account. That's the only thing I have to worry about. Side hustling. So tough. Yeah, like, hey, that's what it's supposed to be like. This math is just a medium. Math is just a medium. All right, math is just a medium. All right, we're just supposed to here to have fun, learn some practical stuff, and then run with it. We just just supposed to have fun with the subject that's normally really boring and dry. I get it. I know for you guys, some of you are going to use it in your day-to-day life, but I know how dry and boring it can be, and sometimes difficult. So, I'm not I'm not underneath any impression that that it won't be like that for some people. But as long as you're having fun with it, then that's just how it is. So that's why that's why I like that's why I like teaching so much, because then um I can just like fool around. I can just like fool around. Hold up, we got homework. Yeah, we got homework on my math lab, bruh. Yeah, it's just like, man. Sometimes you're sitting there like, man, this is boring as hell, and you're like, oh, dude, I gotta, I gotta spice it up a little bit. Maybe in the middle of the stream, I like mukbang. Just like this big old trays of food, whatever. What's homework? That thing that helps you practice, that you probably will wait until the last minute once I announce the test to do, and then realize that you have a lot of problems to do within a short period of time and not have a social life. Yeah, that's homework. That's totally homework. Oh man. All right, let me. Yeah, I had to do that to a student. I actually said that to a student. I'm like, I told her like the homework's due at the end of the semester, and then I looked at her and I just said, it was at this moment she knew she effed up. I'm just like, everybody just like, yep. The look on her face was priceless. So amazing. Uh, all right, let's all right, let's look at one more problem here. One more. Um, let's look at number nine. Number nine here, machine trades. How many pieces of 6 1/4 inch long? How many pieces of 6 1/4 inch long can be cut from 35 metal rods, each 40 inches long? All right. So, how do we do this problem here? What should we do? What do you think we should do here for this problem? Hmm. Find the total length first. Now that's actually all right. That's actually not a bad idea. The problem with that is, all right, so here is the problem with that. Yeah, so we're going to have to divide 40 by 6 1/4. Now let me explain why that needs to be the case. Why it's not 35 times 40 first, and why is it 40 divided by 6 1/4? It's because each one of the rods is separate. It's not like one long piece of metal rod. So we could have cutting waste once we cut these pieces evenly off. That's why that extra cutting waste we get, we're not going to actually factor that into the final result since they're all separate rods altogether. So that's why it's actually 40 divided by 6 1/4 and not the other way around. And I like that answer there, Potato, because it's like, you're kind of thinking I should take the whole length first. If it was connected, I would agree without question. But since it's not, since they're just like 35 rods in a stack, well then yeah, then it has to come 40 divided by 6 1/4, and then throw out the rest. So just want to kind of give that explanation there to say, yeah, okay, order does matter here in that case. All right, and anyway, because of reasons. So let's do 40 divided by that. Okay. So about 6 1/4. Now 6 1/4. Oh, so 6 1/4 here is going to be again at 25 over 4. So we got 40 over 1 if you need to do it that way. You can rewrite that as 40 over 1. Be helpful if I'm not being dumb. Divided by 25 over 4. All right. And we go ahead and flip that fraction over. Okay. So we get and make it multiply. All right. Can anybody tell me what we get here? I can show you the paring down process if you like. So you get 5 and 5 here, by the way. So what do we get here? You get 8 and 8 and 1 and 4 and 5. Okay, so 4 and 5. Okay. So what do we get here in this case? Okay, 32 over 5 is correct. So let's write 32 over 5 as a mixed number. So let's write 32 over 5 as a mixed number, because I agree with your answer there. 32 over 5 is definitely spot on. So what's 32 over 5 as a mixed number? Thirty-two over 5 is a mixed number. Okay, very nice. 6 2/5 is correct. Good. 6 2/5. Now here's the most important part of the process, is actually coming right here. 6 2/5 is absolutely correct. But remember, we only want whole pieces of this cut. So what we're going to do here is we're going to remove the 2/5. We're just to ignore the 2/5 because that's just cutting waste. So in reality, if we want to figure out how many of these rods we can cut, we're going to take the 6 and just the 6 and multiply it by how many metal rods we have, which are 35. So the 2/5 doesn't factor into the final answer because according to the context of the problem, we only want equal length rods from these cuts. So we lost a lot in terms of waste, but that's just how the cookie crumbles. So here we end up with 210 pieces overall for our final result. Are there any questions about that? I want to be sure that that makes sense. No? Okay. Very good. All right. So I'm going to essentially end off here for today. All right. With division, I want to spend a little bit more time with addition and subtraction because we're going to do a lot of examples with that. So oh, yes. How can we get, okay, now that's fair. So what we want to do is how do we get 6 and 2/5? So the way we want to go ahead and do that here really quick is, again, just do 32 divided by 5. And so you're going to get 6, if you do that on a calculator, you're going to get 6.4, I think. But we're just going to take the 6. So we're going to take 6 times 5. 6 times 5 is 30. Then you take the 30, you're going to take the 32, our original 32 that we have here, subtract by 30 to get your remainder, which is 2. So the big number here is 6, and the numerator here is 2, and the denominator here is 5. So that's how we can get 6 and 2/5 to work out that way. Are there any other questions? Okay. So if there are no more questions here for today, then like I said, we'll just end off here. Next time we're going to start with section 2.4, which is the last section of chapter 2, addition and subtraction of fractions. We'll be doing a lot of examples from that section to kind of get you comfortable with that, because I feel it's always the hardest part of this chapter, so I figure, hey, let's spend a little more extra time on that. And then we'll get into decimals here in chapter 3. So we're just kind of working our way up. So we're almost done with chapter 2 already. I know it's been the first week. I know for an 8-week course, it's like, hey, okay, we're already kind of 1/5 of the way through. But the reason why I do that specifically is I like to work ahead because it gives you more time for review once the test stuff comes around, so you can ask me more questions and be like, hey, can we go over such and such topic or whatever. There'll be definitely time for you guys to ask me like review questions, homework questions, whatever. So I want to make some time for that once that time comes. So uh, there's always a rhyme and a reason. But I always take questions anyway. Even before that time. So feel free to ask me questions again through Blackboard or again email, whatever the case may be. Oh yes, right. I forgot about that. One thing to keep in mind, everybody, I kind of forgot to put that on the syllabus, but the 7th, I think it's the 7th of September, which is 2 Mondays from now, is Labor Day. So I think that's Labor Day, right? Um, so I just need to check one more time. Yeah, so Labor Day is on the 7th, all right? So we will not be having class there on Labor Day. So we will be missing one class there on Labor Day. So just put that as a friendly reminder. There will be no class on September the 7th. For the if you Gustavo, if you want, yeah, you can let me know. Sure. If you want to, if you want that option, I can give you that option. Yes. Just let me know. Just let me know ahead of time so I can open it up for you. And you have to make sure all your homework is done. So, but yeah, I can give you that option. Anything else, everybody? Otherwise, we're gonna head out for the weekend. All right, everyone. I hope you have a wonderful weekend. Okay, that's fine. That's not a problem. Um, Everyone, I hope you enjoy your weekend very much. Thank you all again for coming out once again here today. Like I said, we'll finish up chapter 2, start chapter 3, and we are good. All right, everyone, have yourself a wonderful day, and we will all talk to you later. All right, have a great one. See ya. See ya Monday. Bye.